A halophyte is a plant that grows in waters of high salinity, coming into contact with saline water through its roots or by salt spray, such as in saline semi-deserts, mangrove swamps, marshes and sloughs and seashores. An example of a halophyte is the salt marsh grass Spartina alterniflora. Relatively few plant species are halophytes, perhaps only 2% of all plant species. The large majority of plant species are glycophytes, which are not salt-tolerant and are damaged fairly easily by high salinity. Salt tolerance. One quantitative measure of salt tolerance is the total dissolved solids in irrigation water that a plant can tolerate. Seawater typically contains 40 grams per liter of dissolved salts. Beans and rice can tolerate about 1 to 3 grams L, and are considered glycophytes. At the other extreme, Salicornia bigelophii grows well at 70 grams L of dissolved solids, and is a promising halophyte for use as a crop. Plants such as barley and the date palm can tolerate about 5 grams L, and can be considered as marginal halophytes. Adaptation to saline environments by halophytes may take the form of salt tolerance or salt avoidance. Plants that avoid the effects of high salt even though they live in a saline environment may be referred to as facultative halophytes rather than true or obligatory halophytes. For example, a short-lived plant species that completes its reproductive life cycle during periods when the salt concentration is low would be avoiding salt, rather than tolerating it. Or a plant species may maintain a normal internal salt concentration by excreting excess salts through its leaves by way of a high cathode, or by concentrating salts in leaves that later die and drop off. In an effort to improve agricultural production in regions where crops are exposed to salinity, research is focused on improving understanding of the various mechanisms whereby plants respond to salinity stress, so that more robust crop halophytes may be developed. Adaptive responses to salinity stress have been identified at molecular, cellular, metabolic, and physiological levels. Examples: some halophytes are Anemopsis californica, Atriplex, Italia speciosa, Panicum virgatum, Salicornia bigelophii, Spartina alterniflora, Tetragonia tetragonoides. As biofuel, some halophytes are being studied for use as third-generation biofuel precursors. Halophytes such as Salicornia bigelophii can be grown in harsh environments and typically do not compete with food crops for resources, making them promising sources of biodiesel or bioalcohol.